Hey, fourth graders, it's Mrs. Seals back for our next science lab. So for the past couple of weeks, we've been talking about different forms of energy. We are going to continue with that discussion today by talking about thermal energy. So your target says, I can differentiate among forms of energy, including thermal. So hopefully you remember, energy is the ability to cause change or do work. And I gave you an acronym, the word MELT, that has 5 letters, and each of those letters stands for a different form of energy that we're learning about in 4th grade. Hopefully you remember the M in MELT stands for mechanical energy, which is the energy of motion or movement. We talked about that a couple weeks ago. The E stands for electrical energy or electricity, which we talked about last week. The L stands for light energy. The T stands for thermal energy, which means heat. That's what we'll be discussing today. And the S stands for sound energy, which we talked about a couple weeks ago. So let's get started with thermal energy. Thermal energy is energy related to the temperature of an object or substance. So in other words, the more thermal energy an object has, the higher its temperature will be, or the hotter its temperature will be. And we measure thermal energy as temperature, and we use a tool called a thermometer to do so. Thermal energy moves from the warmer substance to the cooler substance. So thermal energy does move, and this movement can cause a change in the state of matter, such as changing a solid to a liquid or a liquid to a gas. So keep in mind that I said thermal energy is related to the temperature of an object or a substance. So hopefully you remember from second and third grade, when we learned about temperature and how thermometers work, I told you that the way a thermometer works is because that red liquid that's inside of it, when it gets heated up, the molecules inside start moving faster and faster and faster, and it causes that red line to go up. That's because in hot objects or hot substances, the molecules move faster. The faster they're moving, the higher the temperature is. So essentially, when you're measuring temperature, you're measuring how fast the molecules are moving. And that's what we call thermal energy. And then as they cool off, the molecules slow down. So the colder it is, the slower the molecules are moving. So how do we use thermal energy in our everyday lives? You can pause the video, look around your house, see what you can find. What are some ways we use heat? Here are some that I thought of. These are just a few. Whenever we're cooking our food, we're using thermal energy. We use thermal energy to heat our homes, whether it's through a fire or even the heater. Also, the candles right here are providing thermal energy. And we use thermal energy when we dry our clothes, excuse me, in the dryer. Additionally, we use thermal energy in some more ways. Whenever you are blow drying your hair, or if you use a straightener or a curling iron or a hot comb, all of those things use thermal energy. When we're ironing our clothes, when you are baking something in the oven, when you build a campfire to cook s'mores or to stay warm, all of those things are ways we use thermal energy. So today we're going to explore thermal energy with an investigation to see how thermal energy moves. Excuse me, I'm going to get a sip of water. All right, so we're going to see how thermal energy moves. So what I'm going to do is I'm going to use these 2 aluminum cans, and these are going to be the ends of my bridge. And then what I'm going to do is I'm going to take a piece of foil, kind of like a strip of foil, and I'm going to use this to kind of build a bridge. The way I'm going to do this is I'm going to fold the ends. I just have allergies, I'm not sick. And kind of connect it, make sure it's nice and secure. And I have my bridge. All right, so what's going to happen is when it's time to start the experiment, I'm going to have a candle that I'm going to light, and it's going to stay right there. On top of my bridge, I'm going to put 3 chocolate chips. I'm going to put 1 chocolate chip. Let me kind of flatten this out a little better. There we go. I'm going to put 1 chocolate chip right here, right above where the candle is going to stay. Can you see that? You see the chocolate chip? All right, that's better. Then I'm going to put 1 chocolate chip in the middle of the bridge, and then I'm going to put 1 chocolate chip on the other end of the bridge. Okay, so we're going to call this one chocolate chip number 1 because it's right above the candle. We'll call this one chocolate chip number 2 and chocolate chip number 3. So what I'm going to do in just a minute when it's time to start is I'm going to light this candle, and we're going to see what happens. So before we start the experiment, I would like for you to make a hypothesis or a prediction about what you think is going to happen. Think about what you know about chocolate chips and how they change when heat is added. So you may be thinking that the chocolate chips are going to melt. Maybe so. I want you to think about this though. Are all the chocolate chips going to melt? Or, because I'm not going to move my candle is going to stay right here underneath chocolate chip number 1 the whole time. So I want to know, is just chocolate chip number 1 going to change from the thermal energy? Or maybe chocolate chip 1 and 2 are going to change from the thermal energy, or maybe you think chocolate chip number 1, 2, and 3 will change from their thermal energy. Maybe you don't think any of the chocolate chips will change, okay? That's a good hypothesis too. So I want you to make your hypothesis. What do you think is going to happen? And when you're ready, you can come back. All right, so whenever we do an experiment with an open flame, we have to take some extra precautions because to stay safe. So I'm going to kind of tie back my hair right here just so, you know, I don't accidentally turn my head and get my hair caught in the fire. Back there in the back of the classroom, can you see there's a fire extinguisher on the wall? Hopefully we won't need it. It's just a precaution. I also have water in case I need to pour it on something to put out a fire. And I also have something right here called a fire blanket, which also puts out fires. So I'm being extra cautious and extra safe whenever doing an experiment with an open flame. We don't want to take any chances when we're dealing with fire, right? All right, so we are about to start our experiment. I'm going to light the candle. I think it's kind of hard for you to see, which I'm sorry about. However, I will describe what is happening because the kids in class, they're going to be recording their observations about the chocolate chips. So remember, an observation isn't just what you see, it's also what you smell, what you hear. We can also observe by tasting and feeling. We won't be doing those today, but we'll definitely be seeing some changes. We'll definitely be smelling and hearing some, maybe even hearing some changes. All right, so I will tell you kind of what's happening. I'm gonna get one more thing, hold on. All right, I just grabbed a little craft stick, and the reason I grabbed this is because chocolate chips, when they're made, they have like a special waxy coating around them that helps them to keep their shape. So even if we don't necessarily see the chocolate start to melt and spread out, I can kind of poke it with this to show you that maybe it has gotten softer and started to melt. But that waxy coating on the outside of them really does a good job of helping them to keep their shape. Okay, but they could still be starting to melt and get softer. All right, so everything is ready to go. I'm going to light my candle. Maybe. All right. So we are just watching now. My candle is lit. It's under chocolate chip number 1. And we will see what happens. It's going to take a couple of minutes. Nothing really happening yet. See something starting to happen. Chocolate chip 1 on the bottom, it's kind of bubbling up. I also see it looks almost like it's sweating, like there are some little drops of moisture on it. That tells me it's starting to heat up. I see the bottom of it kind of starting to bubble up. I don't really see anything happening to chocolate chip 2 or 3 yet. We'll let it go a couple minutes. Couple more minutes, I mean. Does that make it easier for you to see? I know the glare from the windows kind of difficult, makes it harder to see. All right, I'm gonna let it go for about 2 more minutes and then I will show you and we'll talk about what has happened. All right, about 1 more minute. All right, I'm gonna blow out the candle carefully. Going going to use a little bit of water to make sure it's out all the way. All right, so now what I'm going to do, I know that it's hard for you to see from where you are. So I'm going to kind of show you, here, I'm going to take this down, kind of show you and kind of explain what happened and what we noticed. So I noticed that chocolate chip number 1 was starting to kind of burn on the bottom. It kind of looks like a brownie. And then look at it. You notice how soft and squishy and gooey it got? So it definitely got heated up from the candle and kind of started to melt. It didn't melt completely, but remember, I told you that chocolate chips have that special kind of waxy coating on the outside that helps them keep their shape. Let's talk about chocolate chip number 2. Look at chocolate chip number 2. The bottom of it got really soft. It didn't melt as much as chocolate chip 1. The top of it's still hard, but the bottom of it definitely started to melt and spread out. Do you see that? Let's look at chocolate chip 3. Chocolate chip 3 didn't really start to change at all. When I touched the foil underneath where chocolate chip 1 was is very warm. That's where the candle was. And then it's a little bit less warm under 2, and I can't feel the warmth at all under number 3. So the question is, how did chocolate chip number 2 start to melt, even if the candle was only directly under chocolate chip 1? How did the heat get from here to here? And the answer is a very simple explanation, and it is that heat travels. The heat from the candle came up to the aluminum foil, and it traveled through the aluminum foil to chocolate chip number 2. Because the heat was able to travel through the aluminum foil to reach chocolate chip number 2, that means aluminum foil is a conductor of heat. It allows the energy of the heat, of the thermal energy, to pass through it. Remember when we talked about electrical conductors and insulators? It's the same thing, but this is with thermal energy. Aluminum foil is a conductor of thermal energy, and I know that because the aluminum foil allowed the thermal energy to pass through it. Now, would chocolate chip number 3 eventually have melted? Yes. If I had a little bit more time and could have left it going longer, eventually the heat would have traveled all the way through to chocolate chip number 3 and melted it as well. Or maybe if I had a candle that was a little bit taller and higher and could reach the foil a little bit better, it also would have melted faster. But yes, eventually all 3 chocolate chips would have melted, and that's because thermal energy travels, and it's able to travel through aluminum foil because aluminum foil is a conductor of thermal energy. I hope that you guys enjoyed that activity, and I will see you next week. Bye, guys.